Disclaimer. In this video, we will go over the Earth-space relationship. Hold on to your hats, ladies and gentlemen. Your mind will be blown away.
Space, the final frontier.
Space is big, but there actually is a limit.
Misconception! There is no limit to space. It is always expanding by new galaxies and stars being made. One theory a scientist has is the Big Bang, and all galaxies and stars are expanding from that one point.
Really? Well, you just proved me wrong.
Ha!
Hey guys, what's up? So, I've been thinking, are stars giant balls of gas?
No, you're wrong! They're actually big balls of plasma.
Well, how do they all stay together?
There's gravity on the inside pulling them together.
Isn't the sun like a giant planet?
No, it's actually a star. And it's even on the smaller side of all stars. Don't you guys know anything?
Well, I know that the distance to stars is measured in kilometers.
I give up.
Don't worry, Ben. I got this. The distance between stars is measured in light years, which is how far light travels in a year. It's about 9.5 trillion kilometers, and
I know this is a lot to take in. Take Ashley, for example.
How do you find the distance?
parallax.
Wrong way!
Parallax.
Do you see that no sign over there? Have you ever wondered how far away it might be? Well, you can use parallax to find the distance. We use it by comparing the no sign to that far white tower. I will now demonstrate. What you will need for this experiment is a protractor, some measuring tape, a pencil, and 2 pieces of paper. Now, to start the experiment, you take your protractor and you point it at the 90-degree mark to the white sign. Hold it up to the same eye. Make sure it's 90 degrees with the background object. Next, after you've laid your measuring tape on the ground, make sure it's still 90 degrees with the background object. If it is, you're ready to go. Next, you walk along your measuring tape until you reach the 2-foot mark. With the 90-degree mark still on the no sign, find what degree mark the white tower is on. Looks to me like the white tower is on 87 degrees. Do this for 2 more positions, the 4-foot mark and the 8-foot mark. 4 foot, 83 degrees. 8 foot, 81 degrees. Make sure you mark your degrees for each space. The 2-foot mark, the 4-foot mark, and the 8-foot mark. Next, draw a triangle. This will be the measuring tape side, or B. This will be D for distance. And make sure you draw a dotted line at the top. This will be important. Make similar triangles and put them at intervals of 2 feet, 4 feet, and leave the big triangle at 8 feet. We know this was our 90-degree angle right here when we measured it to the distance object. Next, we write down our first angle, 87 degrees. Next, 84. And next, 81. Draw the same dotted lines to each distance object. This dotted line is 90 degrees to this line. Now, none of this is going to make any sense to you without the parallax formula. It goes like this. 1 over 2 pi times 360 degrees over the degrees you just found times b. Now that you have your formula and your angles, we are ready to go. See this symbol here? That's the angle degree symbol. This is where each angle degree symbol will be. Remember that this is 90 degrees right here, so 81 minus 90 degrees equals 9. Do that for the rest, and you have found your angles. Next, plug it into the formula. So we will start with the 2-foot mark.
Wow, that really cleared it up for me. But I have one more question. How are stars made?
Well, there's a mommy and a daddy star.
No, wrong, so wrong. Stars are made in a nebula, which is a collection of gas and dust. The particles are brought together by gravity, and the nuclear fusion occurs, and it makes a protostar.
Wait, do stars become a couple and get married?
Well, there is a type of star system called a binary star, where the two stars rotate around a center of mass. So it's like a marriage in a way.
Oh, okay, I think I got it. But I have one more question. Okay, so how come on Earth we see stars and they're so tiny, but really they're huge?
Well, actually, it's this thing called absolute apparent magnitude. Apparent magnitude is the star's brightness as seen from Earth, and absolute magnitude is a star's brightness, true brightness, and it varies and looks not as bright as from apparent magnitude because of distance.
Gotcha.
Kind of like humans. But do they die like humans?
I'll take this one. Okay, so they can die, but it's not exactly the same thing. There can be a supernova, which is when pressure builds so much that it collapses on itself. This causes a huge explosion. Or it can become a black hole, which tension increases so much that it pulls everything in, including light and dust and rocks and everything. Mind-blowing.
But how do we know all of this?
Well, most of it's just theories, because we can't see some things in space. But we do have telescopes, which enhance the vision of distant objects. Sometimes they're not clear on Earth, but if you put one up in space, like the Hubble, it becomes much clearer.
But isn't there something called a
Spectrograph, and it's a device for breaking down light and recording results photographically. It gives data about the waves.
Wait, why do we need instruments about waves? I mean, we can just go swimming. All I need is a floaty tube.
Yeah.
Not those type of waves. We need waves in the electromagnetic spectrum. See, by learning about these waves, we can learn about the distance of stars from Earth. The further away a star is, the redder the waves will be. It has to do with the frequency of the waves spreading out.
I have taught you all very well, young Padawans, but I have one last thing to say.
I am Coach Dubinsky, and I approve this message.